The squeeze theorem states that if f of x is always in between g and h, and both g and h approach the same limit as x approaches c, then f must approach that same limit as x approaches c. Ultimately, the squeeze theorem is used to prove the special limits below. And I just want to point out that for these three here, these limits are also true for reciprocal. So here we have the limit as theta approaches 0 of sine 3 theta over theta. Now this limit is looking a lot like this first special limit. I just have to manipulate it. I can say the limit as theta approaches 0, and if I multiply the numerator and the denominator by 3, now I have sine 3 theta over 3 theta, which is the same as sine x over x. So that's 1. So my overall limit is 3. Part B, this limit is looking a lot like this limit, the reciprocal of it, which is also true. So I'm going to take this limit, but I'll factor out a theta from the numerator, and that leaves theta over 1 minus cosine theta. So as I plug in 0, I get 0 multiplied by 0, which is 0 overall. Now part C, it's actually connecting to two limits, this one and tangent. So the first thing I want to do here is manipulate it some so that it looks more like these special limits. So I'll multiply by 2x over 2x here for sine. Cosine can stay the same because I can do direct substitution. But on my denominator, I'll multiply by 8x over 8x to create my tangent limit. So now I have the limit as x approaches 0 from the right of 2x times 1 times cosine 5x over 8x times 1. So now my 1's cancel and my x's cancel. And now I can do direct substitution. As I plug in 0 from the right, I get 2 multiplied by 1 over 8, which is 1/4.